best way to install Python either. Okay, I mean it worked. Pip works too now. All right, so let's see. Let's get started. Get some. I don't need help installing it. Let's try. Absolute Beginner's Guide. Okay, NumPy, the absolute basics for beginners. Welcome to the Absolute Beginner's Guide for NumPy. NumPy or NumPy? If you have comments or suggestions, please don't hesitate to reach out. Welcome to NumPy, numerical Python. NumPy is an open source library, Python library that's used in almost every field of science and engineering. It's universal center for working numerical data in Python, and it's at the core of the scientific Python and PyData ecosystems. NumPy users include everyone from beginning coders to experienced researchers doing state-of-the-art scientific and industrial research and development. The NumPy API is used extensively in Pandas, SciPy, Matplotlib, scikit-learn, scikit-image, and other data science and scientific Python packages. The library contains multi-dimensional array and matrix data structures. It provides ND array, a homogeneous n-dimensional array object, which with methods to efficiently operate on it. NumPy can also be used to perform a wide variety of mathematical operations on arrays. It adds powerful data structures like Python that guarantee efficient calculations with arrays and matrices, and it supplies an enormous level of high-level mathematical functions that operate on these arrays and matrices. Learn more about NumPy here. Okay, so we've installed it. Here's a code example. All right. Well, that's not a code example, actually. An array is the central data structure of the NumPy library. An array is a grid of values, and it contains information about the raw data, how to locate an element, how to interpret an element. It's a grid of elements indexed in various ways. Yes, we know what an array is. An array isn't really a native data type in Python, which is kind of interesting. They're called lists in Python. What's the problem with this? You're already could not be resolved. You're already giving me problems. You're already giving me problems here. No such file or directory. Practice. Okay. Well, ran without an error there. So let's see if we could do np. I'm guessing all the API is exposed to this np. Let's try this np dot. All right, and a equals np dot array. 1, 2, 3. Maybe do like printf or print a. That'll a lot of work. Okay, that seems to work. How about print a dot 1 or a like that, a1. Great, that prints the middle element, right? So can we do like a dot length or no? I don't think so. That's JavaScript. All right, cool. That's arrays. That seems pretty easy. What can we do that's a little more fun? We've got sorting arrays. That's fine. Let's keep going here. Size and shape of arrays. So we got dot size. I see. So not dot length, but dot size. Every programming language has its own syntax. All right, let's try something more fun. So Python has some sort of support for some numbers. Let's try two different things. So let's say b is 2 to the 52nd power. Let's see if we can print b here. Let's see what happens. And in JavaScript, if you try to do this, you don't have a good time. All right, 2 to the 50th power is like that. In Python, of course. So here we have a number. Let's try 70. 75th power. Okay, a little bit bigger number. How about 6 or 7 to the 75th power? Alright. So Python has no problem working with numbers this big. 150th power is quite a bit bigger. How about the 350th power? Okay, pages and pages of numbers won't make Python blink, it looks like, which is pretty cool about Python. You can't do this in JavaScript too easily. Right? Very quick, very efficient. Try to do that in JavaScript. In fact, we could just do that right here. Right? Console.log. Or in fact, we don't even need console.log. Let's do the same exact method there. What is it in JavaScript? Math.pow. 7 to the 1200th power is infinity according to JavaScript. Cool. Thanks, JavaScript. 2 to the 10th should be 1024. Oops. And it's 1024. Okay. Let's try 2 to the 22nd. Alright, no problem there. 2 to the 25th. 2 to the 30th. Alright, how about 10 to the 30th? Well, we know what 10 to the 30th is, right? How about 12 to the 35th? Well, we're starting to lose precision here, right? We got e to the E37. I wonder if 9 to the 45th will break. Okay, at some point this will break, right? Probably right after the 100th E. No, it goes higher than that. E115, E219. And we know what the limits are. You can actually do, yeah, so there's a hit the limit there, but you can actually do, you can query the integer object, or the data wrapper, or whatever it's called, the wrapper of the object, and actually get the max data value. But I think you lose a lot of precision here, whereas Python's sort of engineered to have that precision. So, all right, so we can change the orders of arrays, things like that. It's all sort of rudimentary stuff. I don't think we need NumPy for that. Different slicing and dicing of arrays. Okay, we can sum an array, sure. Random numbers. Now we're talking. Sort of pseudo-random, maybe. But okay. Alright, let's see. Pretty simple statistical formula. np.sum, np.square. Okay. Simple stuff. $52 bits. So there's limits to this stuff too, right? Interesting. Oh, base 58. Topic near and dear to my heart. Python has no problem with base 58. Interesting, right? I wonder if we could convert base 58 easily using NumPy. I don't even think you need NumPy, right? There's different, of course, libraries to do this, but I kind of want to do it from scratch. It'd be a good way to learn this. So let's say somebody had a, I don't know, let's see, let's go to the Bitcoin. What's a good Bitcoin private blockchain explorer? Let's just try Bitcoin largest wallets. Maybe look at this one. This one's got, I think this is FTX's. No, I'm sorry, this is Binance's. This is the largest wallet for Bitcoin, I believe. Sorry, am I crazy here with comments in Python or not? // Oh. Feel stupid there. Sorry. No idea. Okay, cool. So let's see. So we're gonna take this string. I guess we can call it like, well, C equals something like this, right? And here we have the REPL down here. So we want to slice this, or we want to sort of do it like a for each or something like that. But this is something complicated. Let's see. We can break this string down. So maybe we could do like, let's see, print C0. How does that work? We do that. Okay, so that works. And then we got what, C.size, right? We could just go to the REPL. Well, let's see. So size doesn't work. That only works, I guess, in NP, right? Length. Yes. All right. Usually in the old days you could press F5 to run. So let's see. All right, so 34 characters here. All right, so let's see. In base 58, let's see. I guess you do a for loop. Let's see, for I, let's see what I don't even remember what the Python for loop syntax is. I don't use this language very often. All right, let's see. For X in C, and Python doesn't have like parentheses and brackets and stuff. You can just rock and roll, right? All right, so let's see. So X, well, let's try just print X for now. Let's see if that works. All right. Okay, so there's the key one by one. So now what we need to do is basically get a running sum, right? So we have to translate these numbers into these letters into numbers. So assume base base 58 starts like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then because it runs out of room, we have to go to the lowercase letters, etc. So we have to build our own little library here. We'll make it a function, and we'll try to call that function. So in Python, how do we define a function? Does anybody know? Let's take a look. Python define a function. Oh, yeah, F5 is my own little. All right, so defining a function is, there we go. Define my function. All right, so we're going to define convert base 58 to decimal. That's maybe not the best name of the function, but this is going to be, it's going to take one argument and return one argument, right? So it's going to take in, we can just say it takes an x. Is that all right? All right, so let's see. What are we returning, right? We got to return something. Is there a return concept in Python? I would hope so. Every language has a return concept. All right. We're going to return something. We'll figure that out in a second. So let's see. I guess we could say like if x, right? What's the Python if syntax? All right, if x is, so we say, can we say that like if it's a number? I think we could do that, right? If x is less than or equal to 9 would be another way to sort of force that. X is, but the problem is if this thing slices the array, I don't think it'll treat the string, right? Even if it's a number in the string, it still treats it as a string. So we'd have to coerce it. And this isn't JavaScript, so coercing it's not going to be necessarily easy, right? Yeah, we'll figure this out in a second. So I think we're gonna. You can typecast easily. All right. I think it's not going to be a digit, right? If x dot is digit. Let's try. Can we do this? Do we need a colon here? All right. Let's try that. We'll skip the return converted for now. Print x. We can say convert base 58 to decimal for every, say, x. Will this work? Doesn't seem to like it. Should we put the function definition upstairs? I don't think that's going to make much of a difference, right? No, it kind of likes that better, it seems like. Alright, let's see, we got some errors here. You mean is digit lower cases? Yes, I did mean is digit lower cases, name. Alright, digit found. It finds a digit in every case, even though it's a string. So I think that's helpful. It might be helpful. Alright, so let's see. Let's try if x is less than or equal to 9, then we're just going to return x. Okay? But I wonder if we could say if x is I wonder if we could do something. We could do this the easy way or the hard way. To do the alphanumeric. The dumb way would be just to enumerate the rest of the base 48, the base 58, 48 more enumerations. I don't know that I like that. We could do it much more intelligently. So if x is a letter, what do you guys think? What do you guys think? Like this. If x is less than z, capital Z, maybe, and if x is greater than lowercase a, then we could say print it's a letter. What do you guys think? Will that work? I don't know about this and thing. Can we nest? What's the syntax there? If x is less than or equal to z, maybe like this. What's the problem with the and? You can write and? I don't think that's right. Write and? Really? Alright. Fine by me. Alright, so here's the problem. String and integers, right? So again, we have typecast issues. So we can we coerce the type? Well, even if we... You want to coerce it? Alright, we could try that. Let's see. Alright. converted equals integer of x. So now let's try print x. See what that gives us. Okay, wait a second. Did we not save? It's weird. It's throwing an error when I had no problem with this code before. Remember? We literally just did this, right? It had no problem with this. It said digit found. Isn't that odd? Did we change anything? I don't think we changed anything. Right? Do you guys remember that? Isn't that bizarre, right? We did this, and I was mystified that it would say every single one of these was a digit, even though they're not. Bizarre. Could we ban the guy that constantly is saying something about VLOOKUP? Release a timeout? Kind of annoying. Alright, so let's see. We can convert it like this, but that doesn't seem like a lot of fun. Invalid literal for integer with base 10x. Okay. This is no longer fun. Okay, so here we're starting over again. That works. This, this worked. Before. Now it's not working. All right. Fine. Fine by me. That's really weird. I feel like I dreamed that it worked, right? Isn't that bizarre? Oh, we did the is digit, right? That's the difference. That's the difference. But it thought every one of these was is digit, right? Like, take a look. If x dot is digit, then let's say print found a digit. This is the code that returned a digit each time. Does anybody know why? It always returns a digit. Doesn't make much sense, right? And then yeah, the ASCII code should work, right? I remember BASIC from a long time ago, like, you know, the A is represented by this and that. So let's see, can we convert? Simply convert. Let's see, since they're digits, we should be able to. Is there an is num? Is digit the right one? Third element shouldn't be a digit, I agree. Alright, let's try this. If x is greater than 9, try try that. Okay, I think we have to add some concatenation here, right? Okay. All of it, this is doing it correctly, so that seems fine. I don't know why this was so difficult. Okay, so what's the coerced value, right, of these ASCII values, right? Oh, it's numeric. That's much better. Thank you. That's so much better. Somebody gave me is digit. All right, this should not have any. Okay. It feels they're all numeric. So I didn't think there was much of a difference there. It looks like there's 34 of them as well, right? Yeah. All right, let's see. If x is greater than 9, then we basically have to revert to this alphanumeric system. And here's how we can do that. All right, so if x is greater than 9, we're going to say that a is 1, right? A is 10? Yeah, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and a is 10. So therefore, we're going to say x minus 10. Is that the way to do it? Let me think. We're trying to measure the distance between the letter x, whatever the alphanumeric figure is in x, and we can add 10 to it and take the length, you know, its base level is going to be 10, so we can say x minus 10. Let's try that. But we still need to coerce, right? I don't think this will work. All right, when in doubt, we can try something like this. Let's see, coerce string to number in Python. Convert. All right, use the int built-in function, right? Okay, looks something like this, int string. All right, but it tells me it's invalid. Invalid literal. Well, let's see what the type, yeah, that's a good idea. Let's see what type comes out, regardless. All right, it's what we expected, strings. So why won't it coerce? Int converts a string to an integer. Okay. Maybe let's say converted equals int x, print converted. Again, invalid literal. Yeah, I just don't think you can do that, right? You can do it something like this, where you have a string that's numeric already, but you can't do it, it's not a number, right? So what we could do, but you can still compare strings, right? Like a is less than b and so forth. So, like for example, let's go to the REPL. Let's say a minus b. Nope. A minus b. There we go. Nope. You can't do that as an operand. Okay, so we'll have to write... Do we have to do this the long way? We might have to do it the long way. I don't want to do it the long way. Yeah, position and the alphabet. Ooh, maybe that's a good idea. We can make... Oh, that's a good idea. I like that. So let's say, make this global variable. Always a good idea, right? Alphabet, or let's say base 58 equals... This is a good idea. Thanks. 8, 9, and now we do A, B, C, D, E, F, G. Oh, wait, these should all be strings. 0, 1. So we only have to type it once, but we could have done this somewhere else. It's maybe not the best way to do this, but yeah, Python's not giving us a lot of wiggle room. I'd be curious how the libraries that are out there that do this, but we're building one from scratch. Is L not in? I think L maybe not be in base 58. Base 58 exceptions. Base 58 excludes 0, capital I, and lowercase l, correct. Okay, L, M, N, what else? Capital O. Okay, so lowercase o is in there, and O, P, Q, R, S, T, U, R, S, O, P, Q, R, S, T, U, V, W, X. Well, I got them all right. Imagine I didn't. Y and Z. Now we do capitals. A, B. Oh, base. Oh shit. Base 58 doesn't have number 0. I forgot that. C, D, that makes shit a lot different. E, F, G. So we're just going to take the array index, right, and use that to do the math. That makes sense. H, and no capital I, right? H, I, J, K, L. I feel really ghetto doing it this way. L, M, and there's no capital O. And that's it. Those are the 4 exceptions. P, Q, R, S, T, U, V, W, X, Y, and Z. All right. Let's see if base 58 or link. I'm still doing JavaScript in my head here. Let's see if this works. All right. FU2. How about that? What? Expecting the block after function definition on line 9. Okay, yeah, there you go. Alright, so base 58 has 58 elements, which is good. Let's see if we can make sure that we got this right. Look at all those parentheses. List object is not callable. It shouldn't be callable. Okay, cool. So we've enumerated this. So now we'll just do it like this. So if x, do we say if x is in? Can we do that? Base 58. x is in base 58. Let's try that. Okay, that seems to work. So how do we return what position it is? Let's try that. Determine if element is an array in Python. Let's try that. Contains? No. Determine. We know how to do that. We did the in. We're trying to determine the index of element in array in Python. There we go. All right. So just the index method. How cool is Python? So easy, right? Let's see. Well, let me get a look at an example at least of how to use this. All right. Dot index. Okay. All right. So let's see. Let's get. Whoa! What's going on here? Get virused. Just got virused right in my JavaScript. Google Chrome exploit. 0-dayed. X dot index of, let's see, base 58. Maybe that'll work. Like that. The other way around. Yep, there we go. Cool. All right. So now we have in essence, the value, right? So let's go look at that private key again. Oh, I mean public key. All right. So 3 is worth 2 in base 58. Isn't that confusing? 4 is worth 3 in base 58. Lowercase x is worth 31 in base 58. So now we're going to have to build the number. Let's take a look. This is getting easier and easier. We're going to return something called sum. All right, so we can get rid of, we can say base 58 that index of x is the value for, here's the problem. We can't just sum these. Each one is exponentiated. In fact, I think we could just return this, right? And that function's done. Cool. Now we can do the additions in here. And so how do we know what the index of the for loop is? That's another question, right? Determine index of for loop. Enumerate? I just want to know what loop we're in. So if that makes sense. So I'd like to print, is it enumerate? Let's see, enumerate x, that doesn't sound right. Let's see. No. Is it, I don't think that's right. Yeah, that's right, Michael. I think that might be the best way to do it, right? Current index equals 0, right? So print current index, and let's watch it go burr. No? Okay, well we gotta increment it. Index plus plus, does that work? for index and x and c. I'll try that. That sounds easier. Thanks for the suggestion. No, that doesn't work. I don't think this works. Cool. All right. Works for me. Let's see. All right. So the first element. Okay. Great. So we're almost ready to sum all this stuff up. So let's see. Tally equals 0. We'll call it sum. Sum equals 0. Will this work? No, wait, well, hold on. First of all, we need to do the exponentiation. So let's see. Okay. Let's try this. Base 58 value equals this. Print index base 58 value. We just did this a little bit different way, but same thing. All right, so now we're going to take the base 58 value and raise it, right? So the new sum, new value, or new summoned is base 58 value star index, right? So we can print new summoned here. That looks right. So in the first position, the value 2 to the 0th power. No, that doesn't work. That doesn't work. It's this is the basis representation theorem from math. If you are familiar with it, very simple number theory. Let's see here. This is maybe the best formulation of it. All right, so you've got the base and then you've got the exponents. We're multiplying the base times the index and the exponent. So let's see. This is new summoned. It's just what we're trying to get for just the one value is the base 58 value, which is A. That's the coefficient, right? We're trying to multiply it first by K, which is the base. And that has to be raised to the index. So that should work. Okay, that makes a lot of sense. So the number 2 in the first position of base 58 will be 2, but the number 3 in the second position is, let's see, it should be 3 to the 50, or 58 to the third power. Is that right? 174? Yeah, because it's 3 plus 58 plus 58 plus 58, 119 plus 58. Maybe not. Let me see here. It's like clock arithmetic. This is the second position. So 3 in the second position, like it's sort of like in binary, right? It's times 3 times 58 to the second, right? 3 times 58. It's just 3 times 58 actually, because it's 58 to the first, this element is 58 to the 0th, or to the 0, which is 1. So this makes a lot of sense. I think we've got the right number. All right. So now let's try. We got new summoned, right? So we're going to do new summoned, or sum equals new summoned plus the original sum. Sum started at 0. I think Python will initiate values at 0, right? So we're just gonna, maybe we'll print sum for every sum and see it grow. Watch the money machine go brr. Hey, what are you doing? I don't know. Will this fix it? Why is it throwing an error there? I'm getting a new number. How is it unsupported? Isn't that wild? Sum is a reserved word. Oh shit. Let's see. Base 10. We'll call base 10. Thank you. Not defined. All right. Am I not defining it right now? Base 10 equals 0. How about that? Does that help? All right. Cool. All right. So this is the base 10 representation of the largest Bitcoin public key, right? And if you had the private key, you would own $5 billion, right? $5 billion of Bitcoin. $6 billion, to be fair, to be accurate. No big deal. Right, but let's see if we got the base 58 representation right. Let's see if there's a base 58 converter. All right, and this is probably going to capture this data. Let's go to see if it converts it the same way we convert it. I'll be so happy if it's right. Well, how about binary? No, we don't want binary, we want decimal, don't we? Decrypt. Please decrypt. All right, well, oh, here we go, integer number, let's try that. We got a different number. Base 10 outside the loop. The whole point is that it increments it. Oh, I see. Yeah, that makes sense. Still the same number. Does that surprise you? You would think it would reevaluate it, right? Yeah, the address is the base 58 representation, correct, of the key. So it says it's this. We're getting a different number, a bigger number. so this is base 58 ciphertext. Maybe we'll try this base 58 plain text and we'll convert. So this is base 58. I want to call it ciphertext, but are we messing something up? Let's try a different decoder. Oh, that's not what we want. We want to decode in integers. Well, let's see if this thing could it be this library's wrong? So look at the first 2 digits, 34. Oh, I see what's going on here. I see what's going on here. We're summing the other way around. Do you see that? Did anybody spot that? We're starting with the wrong index. We got to start with the last one and go forward. We're starting with 3 and 4, I think. Right? Let's go back and see. Little versus big endian. What's going on with my hair? Oh. I need a good haircut. So yeah, so we're going backwards. We have to go the other way around. Yeah, so we gotta, we can fix this pretty quickly, right? We could say, well, we can do, let's see, index minus length of index. Maybe the other way around, length of index minus index. That'll give you the right exponent. Watch it come out with the exact number. Nope. Okay. Length of, not index, length of C. That is so cool. It's exactly kind of what I thought it would look like. And let's go back and see if we can convert this to an integer. Not quite right yet. Maybe getting closer. Maybe it's length of index minus index. Oh, I think it might be -1 too. Yeah, add 1, right? Bola had the same instinct as me. No. When in doubt, -1. None of these numbers were right. Okay, let's see here. Let's not guess. Let's try it this way. Length of C. Right, there's 34. So when we take the first number, let's try that, and then we'll try index. I see. So we do have to add 1.
Market data connection lost.
Shut up.
Market data connection re-established.
Maybe we do subtract 1. I think we do subtract 1. Yeah, we do have to subtract 1. So in the 34th position, the first thing we're doing is the 34th position, right? So we're going to raise this to the length, which is 34, minus the index, which at that point is 0, which is, and then minus 1. So the last one, in fact, we can sort of print out some of what we're doing here.
Market data connection lost. Market data connection re-established.
Okay, this should work. I like this. Hey! 32. Well, we still don't have the number they have, but this is the only tool I have, so base 58 convert their integer. Okay, this might work. This is base 58. And here's the converter, 32 something or other. Right, and is that the same that we got here? Oh, wait, it's our number. Isn't that funny? This one's the wrong one. And this one, well, it's not quite right either. Could you imagine 3 different programs have the wrong number? Mine, this one, and the other one, we all have different numbers. Isn't that weird? No, I don't think you have to add 1 to it, because I think that, like here, maybe you're right, hold on. I hate doing it like this. Let's just... This is the bad Kermit coding practice. Well, is this one? No. Alright, let's get the bad Kermit again. Just do +1. Don't think about the code, just do it. Alright, no, I think it's -1. I think something else is going on here. Order of operations. Well, there's parentheses here. I don't see the problem. Because we're starting with the beginning of the array, right? And that position is being raised to the -1th power. I'm sorry, the power of the whatever position it is, -1. So I think this is all correct, actually. I'm not sure I trust, quite frankly, these tools. I'm not trying to be a jerk. There's a base 58 library, of course, in Python. Should we try it? We can decode back to an integer, I think. Let's try it out. Got some name problems here. Cool. All right, let's try that. Let's see here. What is this? Base 58 decode? I need to decode it into an integer ideally. Let's see if there's some more details here. There's a command line tool. I wish there was some documentation. I don't know if this will work. I don't think so. Need documentation. Oops. Well, it's giving me this weird thing over there. I want something a bit different. So let's see. Yeah, it seems like it wants to take. Hey, we're just off, so there seems to be some difference between their number and our number. So this is the function. This is the library number. Okay, and that last one is our number. So in fact, if you look at this converter, right? This converter seems wrong, which we should probably let these people know. But this converter looked right. Right? Because that gives the same answer as this. So I think this is the gold standard answer, the single source of truth. So there's something in here where we're missing something. There's some error in our code that's getting the number a little off. It's a little off. And it looks like maybe there's just one more iteration we have to do or something here. We're getting pretty close though. You guys are talking about UFC. Unbelievable. Unbelievable. Psh. I never. It's midnight? No way. So what's the error? Good idea. -1, right? What's your suggestion? Anybody? Looks like this array was done correctly. I'm wondering if it actually is an error in here. I want a UFC fight you. A, B, C, D, E, F, G, H, I, J, K, M, L, M, N, OPQRSTUVW XYZ ABCDEFGHJKL. Is it the I? Am I missing the I? I think I might need the I. Capital I, lowercase l are gone. Okay, HIJKLMNO PQRSTUVW and Z. Okay, that looks normal.
Market data connection lost. Market data connection re-established. Market data connection lost. Market data connection re-established. connection lost.
So one strategy here to debug could be just figuring out what's the difference in a much smaller number, right? So you can see there's something going on. Oh, that's an error. So let's just make it a lot smaller and see how the error propagates, right? Numbers are quite close, but it seems like we're not adding one number or something like that.
Market data connection lost.
Huh, look at that. This one you can almost calculate in your
Market
head.
data connection re-established.
It's definitely an off by one error. No, I don't know what it is. So yeah, let's do 34x. 34x is 6957 in decimal, but our program calculates it incorrectly at 6933. It's off by 24. Why? Well, what's the value of x? According to us, it's 31, right? So is it 31 to you guys? No, they think it's 55. Ooh, I think I know what's going on here. Is capital A, how annoying is that? Capital A, oh look at that, you guys are all off. It's the order of capitals versus lowercases. The capitals come before the lowercases in ASCII, I guess. Or at least in this base 59. Isn't that wild? What a crazy error. Isn't that the fun thing about programming? You can spend an hour looking at your code, thinking about it, and then... Whew. Anybody else want to tear their hair out? Alright. Everybody knows the ASCII chart starts with, I mean, I remember as a kid, you know, ASCII was my life, but ASCII hasn't been my life in a while. I used to know all the ASCII by heart, all 255. It's been a long time. Alright, 0 is the difference. We have a base 58 library, as good as the pros. Let's see how many lines of code this is. I would say Osh is better. I'm just kidding.
Market data connection re-established. Market data connection lost.
All right. So this is the private. This is the public key that corresponds to the private key of the largest Bitcoin wallet there is. Now let's maybe generate a private key and a public key. What do you guys think? You want to do that? That sounds fun. Generate public-private key pair Bitcoin.
Market data connection lost.
Should be a lot easier. Bitcoin key generator. Okay. Great. We got a public key and a private key here. Should we note these down? We about to be rich? Okay, that's the private key. It's our public key. Don't send any money here. It's gonna get lost. Alright, so let's forget the Binance's $6 billion. And let's go get the numbers for these. Print, private. Wait, let's convert. We have to convert it. So let's see here. We got to turn this into a function, right? Base 58 Shkreli converter. How about that? We're going to return base 10. Why is this a problem, my friend? Okay, I think that works. Okay. Let's try this. Base 58 Shkreli converter of the private key. Okay. Okay.
Market data connection re-established.
Okay. This isn't a local.
Market data
It's a
connection
local variable. Is it a
re-established.
local variable? Is it really a local variable? Okay, I see. I see your problem. I got you, dog. Okay, yeah, that didn't make much sense there, but hold on here. Oh, yeah. Let's see. So we're sending the private key in. It's calling that X. For every index and X, we'll call that index and Y in X. Convert the Y. Thank you for that. Obviously, there's some variable problems here. And enumerate X. All right, right. Length of this array is X. Okay, great. Cool. All right, so that is the private key. This is the public key. Okay, that didn't work. Why not? Why not? Why no work? We have to reset all these things? Very nice, thank you. Good suggestion. That's definitely messing up the results. Alright, so now we'll try the libraries one. Public. See if they're the same numbers. Hey. Takes 2 arguments. Stop. Right, same numbers. Right, so this key is related to that key by some magic method. We don't know what that magic method is, do we? But I wonder if there's, I don't know, let's see if there's like a ratio between the two of them. What do you guys think? One is like 3 times bigger than the other. Interesting. Okay. Let's make another address.
Market data connection lost. Market data connection re-established.
See, Excel won't take these numbers. They're too big. Watch what happens if I try to put this number in Excel. Huh? Doesn't mind it that much. That's good. Let me try it then. Take it as a string. Do you guys want the Binance private key? Anybody want that? It's got 6 bill. 6 billy. Okay. So how do we go from here to there? That's the big question, right? You don't. You can't. Let's take a look. So this is varies by 4. So it's a lot of numbers. But I wonder. I wonder if you could build a rainbow table. People say things are impossible, and then they end up being possible. This is a big number as well, right? The private key difference between these 2 private keys is very large. I wonder how many numbers that is actually. Let's go to the public key. All right, so there's well, yes, of course they're different. Yes, they're not prime numbers at all. In fact, well, these are elliptic curves. The SHA is prime numbers, but the SHA is deterministic. Yeah, exactly. Exactly, MR. You hit it on the head. All right, well, let's try another one. Oh, look at that. You don't even have to insert entropy. It just does it right away. That's much better. And we can create another little library that'll make billions of these, maybe billions of these a second. But for now, let's do a couple more manually and see if we can see a couple of trends. Alright, so here it was, they differ by 6. Well, if you've multiplied by 6.5, right? Well, 6.5 to the 33rd, you'd have actually a range of values that you can query. It would be a large number, but possibly a tractable number. Because notice all the decimal values of these numbers all right next to each other. Now you're still looking at really large numbers, but private key number is enormous.
Market data connection loss.
Oh, shut up.
Market data connection re-established.
I can't believe it's midnight already. I have so many things to do tomorrow. You have no idea. And I'm just getting started here. I'm having fun. Oh, there it's differs by 9-fold. Interesting, huh? Let's see. This is a private key. This is a public key. Preferred the exponential notation. Alright, a couple more data points would give us a better plot, which is kind of fun too. It's a new one, right? Alright. If this is anybody's private key by accident, I'm sorry. I'm really sorry. I didn't mean it. I didn't mean it. That would be unfortunate. Oh, phew. It was yours, but you don't have any money in it? Oh, thank God. That was a close call. Hope you guys get the humor. Alright, so that one's even bigger. And it's funny because every single sequential thing address we created, they're two different. They're bigger each time. I wonder if that's an accident. It's gotta be an accident, I would think. But you know, there's I don't know, a lot to say on this. We'll get to it later. supposed to, the whole point of like these types of encryption systems is that there's supposed to, a small change in one number leads to a very large change in another, in the other number. But I wonder if that's necessarily true. It looks like it's true when you do SHA, but I'm not sure it's as true here. And then you kind of use SHA to mask over it, which I don't know. Let's actually try something after we do this one. I wonder how this will work. So that one's 3e to the 33, so that's more normal value. So it looks like they cluster around, when you multiply the public key by 7, roughly, to get the private key within a pretty large error margin, right? Or margin of error. So let's see here. This is the public key. This is the public key in decimal form. This is the private key in string form. This is the private key in decimal form. And now we have changed these values. So it looks like there's some standard deviation, but roughly we also can say a sort of maximum value, sort of 2.
Market data connection lost.
And the minimum value.
Market data connection re-established.
Cool. Can't include that value. Okay. Great. Right, now let's try something fun. Let's take this key, right? And we're just going to increment it by 1. Okay, so I'm going to take this key and change that to a 4. A 3 to a 4, that's it. And we're going to see, how does the private key change? Does it change by a lot? Does it change by a little? I wonder. Well, now we have to actually, well, let's do it the other way. Let's take the private key and improve it by 1. Now we'll see how much the private key changes. We can't do the other way around. Alright, so let's see.
Market data connection lost.
We're going to need a different website that goes from private key to public key. Get public key from private Bitcoin. I just paste in my private key.
Market data connection re-established.
There should be some kind of, there we go. Alright, private key. Well, we need to convert this to base 58, right? So let's see, convert. Well, we do know that, let's see, we could do encode, right? We can do this encoder. We didn't build an encoder, but we can use the encoder. Print base58.b58 encode. Is it encode int? Yeah, I think it is. Let's try 2 numbers. Gives us the base 58. Okay, that's fine. And you notice that they're one after another sequentially, right? This is KX blah blah blah. right? Just like that one. This is, instead of N, the next letter in base 58 is P. So let's go to this. Let's make sure that this correctly goes to our public key. Does it? This is the private key. It's a little strange, isn't it? Did we do it right? Let's see. Well, this will generate it. Well, this is nice. Let's see, private key convert public key Bitcoin. I need a tool that'll do this without diving into GitHub. Well, there we go. Private key to address converter. Let's try that. Okay, cool. And this is deterministic, so it should always be 1K F4, right? But it's not showing up like that. It's showing up a little bit differently. Maybe this is the private key we have to enter. Well, we're not supposed to enter it there. It's a with private key. Well, this site is giving us something that we can still use, right? Because if this is the address, this isn't really a public key, this is the address. It's a bit different. Regardless.
Trading connection lost.
Oh, shut up. Let's try to do it this way. I think you'll see kind of what I'm getting at. Well, that doesn't make much sense. This isn't converting, I don't think. I don't think this is doing what
Trading connection re-established.
Trying to get it to do. But maybe we'll save this for another day since we're getting late in the day here. But this looks like a nice website. This was a lot of fun. This also looks like a good website. I need a vanity wallet. Alright, that was a lot of fun. Alright, probably time to go to bed. I have a long, busy day of work tomorrow, so I really enjoyed hanging out with you guys, spending time. It's a lot of fun. I got my second monitor set up, which is awesome. I'll see you all soon.